Okay, this is my second example of simplifying with index laws when we have different numbered bases. Okay, so we're looking here. The first thing I want to try and do is get the same base number. So I've got a 2 in the first spot, but an 8 in the second spot, and a 32 in the third spot. So I do not have the same bases. I cannot go straight to my index laws yet. So the first thing I'm going to do is rewrite these with their prime factors as the base numbers. So the example that I have done previously, I want to actually find out what are the prime factors for my bases. So 2 is already a prime number. I can't make this any simpler. It's going to stay exactly as it is over here. That part's fine. But then I go to my 8. 8's not a prime number, so I'm going to work out what are the prime factors of 8. And you might know already that it is 2 to the power of 3. But if you don't know that it's 2 to the power of 3 and you've got to work that out, the way I do this is with a simple factor tree. So 8 can be split up into 2 times 4. 2 is a prime number. 4 is not. 4 can be split up into 2 times 2. They're both prime numbers now. So 8 is the same as 2 times 2 times 2, which is the same as 2 to the power of 3. Why am I doing that? What am I going to do? I'm going to bring that over here and stick that into this expression instead. So I already had a 2 to the power of negative 3, and then I'm going to multiply that by 2 to the power of 3, that was the 8, to the power of 4. So my 8 has been replaced with a 2 to the power of 3. Okay, let's keep going now. 32. Let's break this up. You might already be able to do that in your head, but I'm going to pretend that you can't. So it's 2 times 16. 2 is a prime number. 16 is the same as 2 times 8. 2 is a prime number. 8 is the same as 2 times 4. 2 is a prime number, and 4 is 2 times 2. Both prime numbers, so 32 is the same as 2 times 2 times 2 times 2 times 2, or with index notation, 2 to the power of 5. So I'm going to replace the 32 with a 2 to the power of 5. So 32 becomes 2 to the power of 5, and we've got to the power of negative 3. All right, bottom line, we have a 4. Now, I'm not going to do the factor tree. I know that 4 is the same as 2 squared, and it's to the power of minus 4 times 2 to the minus 2. So why have I done this? I've created a problem now where all of my base numbers are all 2's. So now that they're all 2's, I can start to apply my index laws. The first index law I'm going to use is for my brackets here, and when I have a power to a power, I multiply the powers. So let's rewrite this out now. I'm going to have 2 to the negative 3. I've just copied that down. And then 3 times 4, power to a power, that becomes 2 to the power of 12. 5 times negative 3 becomes 2 to the power of minus 15, or negative 15, I should say negative, not minus. 2 to the power of negative, start that again, 2 to the power of 2 to the power of negative 4, power to a power, multiply them, becomes 2 to the power of negative 8, and then finally the 2 to the power of negative 2. All right, so first step, we've got rid of the brackets. Next step, we're going to work with our numerator and our denominator separately. So I'm going to do the multiplication on the numerator. When I multiply, I keep the base, add the powers. So it's going to become 2 to the power of negative 3 plus 12 plus negative 15 on the numerator. And then on the denominator, it'll be 2 to the power of negative 8 plus negative 2. Now I don't try and move the negatives around at all. I just keep them when I work with negative numbers at this stage. I'm going to show you how I manage the negatives in a moment. So my numerator becomes 2 to the power of negative 3 plus 12 is positive 9, plus negative 15 becomes negative 6. And then on the numerator, on the denominator, 2 to the power of negative 8 plus negative 2 is 2 to the power of negative 10. My next index law, I am dividing. So how do I manage division? I'm going to keep the base and subtract the powers. So it's 2 to the power of negative 6 minus negative 10, which is 2 to the power of positive 4. And you can see by not worrying about the negatives till the very end, I haven't had to swap any numbers from the numerator to the denominator. And this is my ideal situation where I don't have to worry about rearranging whether the negatives are on the numerator or denominator and playing around with negative index laws. Okay, so that's my final answer, 2 to the power of 4. If you wanted, given that the first question had numbers like 32 in there and it wasn't all prime factorisation, the answer 2 to the power of 4 we could just write as a normal whole number and make this equal to 16 if you like. So I could evaluate it, say 2 to the power of 4 is equal to 16. Multiple choice question on a test might have this as your answer, or it might have this as the answer, so it's good to be able to do both. Okay, that was my second example. Hopefully that made sense. Thanks.